Now in the second component, we're keeping this additives theme and we're looking specifically at color additives, recalling that food additives and color additives are a special area of regulation, an area that, if not followed, fits into that adulteration that we talked about in week 3, I believe. So also remember that when we're talking about this, we're doing topic-based, so this is going to apply both to USDA and to FDA through this One Enabling Act. So we didn't always have the color additives amendment that we had mentioned in the reading in the article. We, as everything in this area, started with the 1906 Food and Drug Act. And the Bureau of Chemistry that the USDA had was the precursor for the FDA. That was where the Food and Drug Act was implemented, interpreted, and enforced. And initially in 1906 we had this familiar standard of a prohibition against poisonous and deleterious, in this case, colors. And so that standard was applied to all additives of food, and it applied to colors in confectionaries, and in particular addressing what Upton Sinclair had found was the coloring or staining of food to conceal damage or to hide that there was some filler or something else in it. And so we initially had this idea that these synthetic colors would be allowed in, they would be determined to be safe if they were harmless and suitable. And as you can imagine, in some of the cases we've seen how the courts take this one word and try and figure out what it means. What the FDA said to industry was harmless means harmless at any level, completely non-injurious, non-poisonous, harmless. And so that is a really tough standard to meet. How do you begin to meet that? And so it became a completely unworkable standard, but the FDA used it from 1906 to 1938, and then even later when we see that we don't get the food color additive amendment until the 60s. So we had a very long time of the requiring of listing of colors, the certification program, and the standard of harmless. But eventually we got this color additive amendment. And we can see that now in section 201T, and it talks about our definition for what is a color additive, and then we have other statutory sections that go through the process for color additives. And so a color additive is a very broad term. It fits both the synthetics and the natural occurring that we would think. Anything that is going to color a product, we're going to identify as a color additive. And this is applying, the statutory section that we have applies to the full gamut of what the FDA regulates as well as what the USDA works with. So we're talking about in foods and drugs and cosmetics and so on. So anything that's bringing color into an FDA regulated product is going to fall under this definition of color. So this is probably one of those areas where it's rather intuitive to think about what a color is and to be able to go from there. So we saw when we looked at food additives in the first component for this week that there were 3 doors that you could enter a food additive into, and if you didn't enter through one of those doors, then the product was deemed adulterated because it had an unapproved food additive. We have a similar process here for color additives, but there's a limited number of doors. So we have 2 doors that color additives can enter, and if it doesn't enter through one of these doors, then we have an unapproved color additive, and that would be a form of adulteration and so on. And the first door that we can go through is what the FDA calls certified colors, and this is for the synthetic colors, those petroleum-based. They're called coal tar dyes. They're, as you can see, this Title 21 Subpart 74 lists all of the certified colors, and as you can see in this identity statement for blue number 1, very, very specific chemical composition, very strict standards for specifications for purity. It's batch tested every time it's used. Certified colors are very strictly enforced and have a very strict standard to meet. There's a petition process that we'll talk about, that you can get a new certified color listed on, but for the most part, this list is set. We have 9 certified colors, which is pretty remarkable to think about, that in this wide gamut of colors that are possible, chemical combinations we could have, that we only have 9, and as we'll get into, there's some reasons why we only have 9. So this is one area, one door that you can get through. You can follow one of the identities that is currently certified, or you can go through a petition process to get a new certified color. But certified colors are, think of those as the synthetic, those chemical-based colors. So if you're not a certified color, then your only other option to get in and have approved color additive is to have an exempt color. An exempt from certification are dyes or pigments that are derived from natural sources. We're talking things coming from vegetables, animals, minerals. An example, the cochineal extract I have a video on that we'll look at, and that's made from bugs. Burning or heating sugar, and you get caramel color at a very simple level. There's, of course, more complicated mass production techniques that we have for that. There still is this petition process to make sure that it's exempt, and to make sure that meeting the identity requirements and meeting the specifications on identity and for purity. And you'll see that petition process for exempt colors in subpart 73 in the Code of Federal Regulations. And that's it. That is our 2 doors to get into a color additive. There is no generally recognized as safe for color additives. And that's a huge distinction that we have when we're talking about food additives and we're talking about color additives. And that's why I like, when I talk about these, to break them apart. And we can't really have one conversation about food additives and lump this in here, because it's easy to think of this as applying. So you either have to go through the petition process and have a certified color, or have an exempt color. So you're either having a synthetic color that you're proving safety, or you're having this exempt color that you're showing is derived from these natural sources. And if none of those 2 are met, then we, as we're emphasizing, we have an adulterated, unapproved food coloring. So it gets really interesting when we talk about the labeling of these, how these appear on the label, who's required to have them labeled. You would think that oftentimes with consumers, that if we put it on the label, it's sufficient to bring their attention to it and to be enough to avoid some headaches there. And as we're kind of talking about in this class, there is this tension that facilities experience in trying to comply with the regulations. And that tension is between compliance with the regulatory body, the FDA or the USDA, and then providing enough disclosure to the consumer so that they are comfortable with what the product is. And this video talks about Starbucks' decision to use cochineal extract, that extract from bugs, and the public reaction to that. And we'll come back at the end to talk about some of the issues involving this and the extent that labeling helps and doesn't help.
Customers at Starbucks, they're saying the coffee giant has gone too far in trying to make an ingredient in one of its frozen drinks more natural. Mike Sugarman shows us why crushed insects are now part of the recipe for one Frappuccino flavor.
This story may color your opinion. It may bug you. It's about a popular Starbucks drink. Oh, can I get a strawberry Frappuccino? This drink has a few bugs to be worked out because the strawberry Frappuccino uses bugs to get its color. That's the headline.
Starbucks, strawberry Frappuccino colored by insects.
This came to light when a Starbucks barista noticed a new ingredient on the strawberry sauce. It's cochineal extract.
Sounds otherworldly.
No, it is of this world, but to find it, you might want to visit the bug section of the California Academy of Sciences.
It's juicy.
It's juicy, yeah.
It's red juice, yeah.
Norm Penny is the collections manager of the entomology department. Crushed cochineals have been used since the 1500s as red dye in fabrics.
Well, it's the internal juices. It's a carminic acid from the insect that creates the bright red coloration.
So strawberry frappuccino, which has been vegan in the past, isn't anymore. Vegans don't eat dead bugs.
That sounds just ridiculous.
Barista Ben McClintock at Mojo's in San Francisco doesn't use cochineal in his frappuccino. He doesn't actually make frappuccinos. That's kind of a made-up Starbucks thing. Starbucks says in a statement, the strawberry base isn't a vegan product, but it helps us to move away from artificial dyes, which it says is one of its goals.
I've actually heard there's liquors that are flavored with bugs.
He's right. Ketchup, ice cream, candy, a lot of things. The FDA says it's safe, but there is a movement for Starbucks to get the bugs out of this drink. Mike Sugarman, CBS 5.
So this example isn't necessarily perfect for our purposes. Starbucks, being a food service chain, isn't required to put on your Frappuccino cochineal extract. So if there hadn't been that disclosure by the barista, we wouldn't have had that. But this is in the grocery store aisle. You can find any product that is claiming to use natural dyes that is red, most likely is using this extract. And so we have this question that we'll get into next week about what do we put on the label, and when we put it on the label, is it enough to say we told you so? We have some litigation that we'll look at around those issues. And then we also have this idea of additional labeling that needs to go on. And so not only is it about informing the public that the product is being used, but also that there are some implications for that in terms of being vegan, kosher, and so on, that we're using a natural product and that may have some consequences if people have some religious or dietary restrictions on the way they eat. And it also raises the question of whether we should extend our labeling beyond where we currently have it. And that'd be a discussion under state law mostly, to see whether or not restaurants and food service areas should be required, because they're receiving it from the manufacturer or the distributor labeled with these extracts. Should they be required also to disclose that? So it's an interesting example where you're technically in compliance, you're following the regulations, but the consumers have a reaction to something, and is this balance between technically complying with food additives, food color additives, and then having this reaction in this way. So as I mentioned, there's a petition for color additives, and a little easier in some ways than what we had for the food additives. Still this convincing evidence threshold, and still animal studies to show, very similar to what we saw with the food additives, large doses, long periods of time to make sure that they're safe. Really, the FDA is looking at the composition and the properties. They want to make sure that if someone is consuming a lot of this, we'll get into an example where soft drinks are colored, and if consumers are exceeding what would normally be the daily intake for that product, is there going to be a consequence from having the color additive? Been a lot of debate about different color additives effects on children, and so a lot of these questions get raised in the petition process for new color additives. And so a high bar to meet, but different questions, different analysis than we look at for food additives normally. So not a lot of regulation or prohibitions or restrictions in this area. We really just have to follow this petition process and fit into one of the two areas of approval, exemption or certified. The only major restriction that we see, or the major constraint that we can put on color additives, is the Delaney clause. And that's mentioned a little bit in the article that we talked about, and we talked about it as well with adulteration and the history of our statute, our progression of statutory amendments. But the Delaney clause prohibits any food substance that has been shown to cause cancer in animals or man, regardless of the dose. So if it's carcinogenic, then it cannot be present, and that's true for color additives, food additives, everything. So that's the main constraint that we have here, and so what we'll see in this video is a discussion about when does the science reach a level that is sufficient to support a Delaney Clause prohibition.
Soda, you don't expect it to be a health food, but did you know some soft drinks can contain a chemical that's a potential carcinogen? It's called 4-MeI, and you've probably never heard of it. What's 4-MeI? It's a chemical created in manufacturing certain types of caramel coloring used in many foods and sodas. A 2-year government study showed it caused cancer in mice. How can you tell if your soda has it? It's not easy. There are actually 4 types of caramel coloring, and 2 can contain 4-MeI, but you can't tell which type you're drinking. All the label says is that it has caramel color or artificial color. How much 4-MeI is actually in soda? Consumer Reports recently conducted tests of several popular sodas and other drinks, including Pepsi, Coke, and Malta Goya, bought in California and around New York. We tested soda because Americans drink so much of it. Nearly half of us average 2.5 glasses a day. Of the 110 cans we tested, all the ones with caramel coloring contained varying amounts of 4-MeI. But how much is okay? There are no federal limits on 4-MeI, though California requires food sold there to carry a cancer warning label if the product exposes the consumer to more than 29 micrograms per day. So how did the beverages Consumer Reports tested stack up? While our sample size is not big enough to recommend one brand over another, all the cans of Pepsi 1 we tested were above 29 micrograms. And 15 of the 16 bottles of Malta Goya had more than 10 times that level. None purchased in California carried a cancer warning label. With some of the other soft drinks tested, if you have more than 1 can a day, you'd be over 29 micrograms. What about Coke? Actually, all of the Coke we tested had very low amounts of 4-MeI, and drinking 1 can per day would pose close to a negligible cancer risk. Given the scope of our tests, we don't know if all Coke across the country is similarly low, but our results show that it's possible to get a brown beverage without a lot of 4-MeI. You can find out more about our tests and our findings at consumerreports.org. We are urging the federal government to set a limit on 4-MeI and to require manufacturers to list the specific type of caramel coloring they're using on the label. While Consumer Reports cannot say that any of the products it tested violates California law, we believe that some of the levels we found are too high, and we have asked the California Attorney General to investigate.
So multiple interesting levels there. California requiring disclosure, but what about the Delaney Clause that would seem to trump? And so we have this tension between state and federal law that's shown here. But what the FDA has said, and they've also responded to this consumer report that came out, the study that came out the late 2013, is that they've studied the caramel coloring and they have determined that it's safe, and they're continuing to monitor and to look at it. And so there hasn't been a Delaney Clause trigger there. But if that science eventually gets to the point where it is showing, a presence of cancer in animals, it would have to be removed. And so that is one of the constraints that we see, and one of the reasons why we only see 9 certified colors. And if you're old enough to remember, there was a period of time when you couldn't find red M&Ms. The red number 2 had been banned as a possible carcinogen. It's not the only color that has been banned. There's at least 10 on this list. Everything pretty much centered on the Delaney Clause, cancer-causing liver cancer, possible carcinogen. You go through this list, and most of those are based on cancer. Some are not. Some, looking at yellow 1 and 2, yellow 3, yellow 4, those weren't focused on cancer, but still the scientific evidence came out that the FDA decided to pull its approval for those. So it's interesting to think, if we've slowly been eliminating our synthetic colors, will we reach a point where, all of the traditional synthetic colors that we've had will be on this list as banned. So that's the general overview of color additives. We have no gloss. That's important to remember. We have to fit into 2 categories. We either have to be the certified color or an exempt color. and everything is going through a petition process for examination. So if it's not in that system, then we're under adulteration as well. And keep these case studies that we have in these videos that we're looking at in mind. They're really important as we get into this next discussion in next week about personal liability, criminal liability, looking at lawsuits coming from consumers. And what we'll focus on there next week is the consumer's relationship with the label. Here we talked about all the technical components about how to disclose and to comply with these components, not only to meet the standards so it's not adulterated, but also to meet the standards so it's not misbranded, and how that compliance comports with consumers' relationship with the label. So we'll round out this week, though, with looking at irradiation, and then we'll get into those topics that I mentioned for next week.